Hi, my name is James Duffy. I'm the director of platform engineering at Lantern. It's a healthcare a tech company. And I've spent the last few years watching the engineering interview process fall further and further behind uh, the reality of how engineers actually work. And today we're going to fix that. We all know the fear. Everyone's afraid AI is going to take our jobs, and it's driving a very specific and a very wrong response in how companies are hiring. And I used to be afraid too. But here's the actual threat. Not AI will take your job. The real statement is people who know how to use AI effectively will take the jobs of people who don't. That is a fundamentally different problem and requires a fundamentally different response. If that's the world we're hiring into, then why are we running interviews to catch people who know how to Google? Some companies require coding on a whiteboard and don't allow access to the internet or external resources. So raise your hands if you allow candidates to use the internet during the interview. Yeah, really just only a couple. So keep your hands up. Do you allow them to use AI during their interview? Yeah. Okay. You just have two. And I think you guys are together. So now, do you require them to use AI during the interview? Okay. One, and we're even at LLMday. That's crazy. So the current response is banning ChatGPT, Claude in interviews, adding AI detection software, forcing candidates to write code on a whiteboard with no IDE, no documentation. In 2026, if we can catch them using AI, we know they can't really code, right? But that logic has a fatal flaw. The jobs don't have those restrictions. You're testing for a world that no longer exists. Your candidates are already using AI in production every single day. The person you hired last quarter is using Claude Code already for all their PRs. The question was never whether they use it. The question is whether they use it well. Your interview process is testing for a skill that is increasingly irrelevant. The ability to write code from scratch under time pressure with no tooling, that's not the job. If your candidate is using AI as a crutch, you absolutely want to catch them, but that you're catching them wrong. The crutch user will fail faster in an AI-enabled interview than a traditional one. And as long as you change what you're testing. Right now, your interview can't tell the difference between the engineer who uses AI as a superpower and the one who uses it as a crutch. They look identical when all you're watching is who can produce syntax correct functions under pressure. The good news is they look very different when you change the test. The AI is a confident but incompetent junior engineer. It generates code with total certainty. It doesn't say, I'm not sure about the configuration here. It writes a complete professionally formatted solution that will deploy successfully and then break in production in at least 3 different ways. And it does this almost every time. So the candidate's job in this interview is not to write the code. Their job is to save production from what the AI just wrote. That's the format. And we have 2 acts. Act 1, you mandate the candidate uses AI to generate a solution to a non-trivial problem. You give them the prompt and let them generate an answer. Act 2, you ask them to walk through the output. That's it. 2 acts. The magic is entirely in Act 2 because what you're watching isn't typing speed. You're watching how they think. And here's the prompt that I've used in the past. The key word here is non-trivial. This problem requires understanding of AKS, networking, private DNS resolution, managed identity, role assignments, and Kubernetes in general. If you give the AI a simple problem, it might actually solve it. You need complexity because complexity is where the AI will fail. In about 30 seconds, the AI will generate something that looks impressive, lots of resources, good formatting, confident variable names. It will even look like a senior engineer wrote it, but it wasn't. What you get is a long block of Terraform that covers all the obvious resources, the cluster, the node pool, the DNS zone, the managed identity. It looks complete. It's formatted well. If you squint at it, you might think it's ready to apply, and it's not. It has at least 3 categories of problems baked in, and the candidate's job is to find them before you say anything. So you let the code generate. You do not react. You do not say interesting. You don't say take your time. You sit on your hands and ask one question. Walk me through this. Is it ready for production? That's it. No hints. No follow-ups yet. So no, what about the DNS zone? You let them go. The clock starts now. And what happens in the next 5 minutes will tell you everything you need to know. And you have to resist the urge to help. The discomfort you feel watching them struggle is not a problem with the format. It is this format. The discomfort is the test. So what you're watching for is not whether they can read the code. What you're watching for is whether they evaluate it or just narrate it. That's the massive difference. The candidate who narrates it will say, here we have a Kubernetes cluster and it's creating a private zone. Here's the DNS zone. They're describing what they see. The candidate who evaluates will say, hold on, this DNS zone is defined, but I don't see a VNet link anywhere. The cluster won't be able to resolve anything. They are catching what's missing. And there are 3 categories of failures in AI generated code that I expect the candidate to catch. Number 1, the happy path fallacy. The AI generates resources in isolation. It creates each resource correctly. The syntax is right. The arguments are valid, but it's missing the glue that makes everything work together. The Terraform plan will pass. The Ply will succeed. The cluster will exist, and it will be completely non-functional. This is an operational failure. The 2 most common problems in the AKS, the AI generates a private DNS zone, forgets to link it to the virtual network. Without that link, the cluster can't resolve internal names and is effectively a very expensive brick. And the AI creates a managed identity, but skips the role assignment. So the identity exists, but it can't actually do anything. Number 2, the default trap. AI optimizes for getting things to run on the first try. The easiest way to do this is to remove all security friction, wide open firewall rules, public network access enabled, default encryption. The code is functional, but it's dangerous. A couple examples, 0.0 on a firewall or security group rule means allow traffic from the entire internet. The AI puts it there because it means nothing will block the connection during a demo, but in production, it's an open door. Second, enable public network access on a database that should be private. They enables it to avoid connectivity issues. An engineer catches this immediately. Third, default encryption keys instead of customer managed keys. This is a compliance failure in most enterprise environments. And lastly, the time traveler. AI training data is historical. The model has seen millions of tutorials from Stack Overflow, GitHub repos, most of which were written before 2023. It will confidently generate patterns that were standard practice 2 or 3 years ago and are now deprecated or retired. The code deploys, it even works for now, but you've created tech debt on day 1. The clearest example in this is AKS again, platform engineer here. Pod identity versus workload identity. Pod identity is deprecated. Workload identity is the current solution, but AI still generates pod identity like 60% of the time because it's overrepresented in the training. So here, what does this actually measure? It's 2 things. Governance. Can this person audit AI output? Do they have enough domain knowledge and critical thinking to catch what AI missed without being told where to look? That's the skill that matters in an AI-enabled engineering team. AI competency. Do they know how to use AI as a tool to iterate on it, challenge it, improve it, versus just accepting whatever it produces? These are the skills that will survive the next 10 years. The ability to type syntax from memory is not. Okay. Here's how to start. Step 1, pick a non-trivial prompt from your actual stack. A toy example, something that requires understanding of the systems your team actually runs. The prompt only works if the problem has enough complexity to expose those 3 AI failures. Step 2, before you roll this out to any candidate, run it yourself. Prompt the AI, take the output, and document every flaw that you find. build your scoring rubric from that. And now you know exactly what to look for when you bring on your candidates and why. And step 3, calibrate your interviewers. This is an entirely different way to kind of interview people. And if you bring in other interviewers, they're not going to know what to look for yet. And if 2 interviewers score the same session differently, basically your signal is noise. And everyone needs to be looking for those 3 failure modes at least. Okay. And what do we value in engineers now? Critical thinking over recall, verification over generation, architectural judgment over syntax mastery, AI orchestration over manual implementation. These are the skills that compound. These are the skills that make teams better. These are the skills your interview process should be selecting for. The engineers who define the next decade of software are the ones who can direct AI effectively and catch it when it fails. If your hiring process isn't selecting for that, you're optimizing for the wrong thing. I know I went really fast with that. I'm going to get us back on time.